The other day, while trying to figure out how many apples I could gather from my orchard in a day, I ran into the problem of there being continuous and discrete things, the latter of which I can use numbers to count, but the former of which are more complicated. Continuous things are things that, for all practical purposes, I can always split into more smaller things. Clay is continuous because if I have a lump of clay, I can split it into two smaller lumps of clay. Apples are not continuous, because I can't split up an apple into two smaller apples. While I can't use numbers to count continuous things directly, I did figure out a way to measure them. I choose some particular amount of that thing and say that, for the purposes of the problem at hand, I'm treating any smaller amount of that thing as though it didn't exist. I call these amounts units, and while I need to be careful to use the right unit for the job, they let me use numbers to keep track of continuous things as well. I discovered that I can use this to figure out how many apples I can gather in a day by measuring how many minutes it takes me to gather the apples from one tree and move to the next, and dividing the total amount of time I can work in a day by that number of minutes. After spending some time experimenting, I can say that it takes me between 15 and 24 minutes for each tree, from which I gather between 6 and 9 apples. Today, I want to try and get a better understanding of how this all works, and how I can apply the data I've gathered in a useful way. As you would expect, different trees take different amounts of time to pluck all the apples from. Some are taller and take longer to climb. Some have fewer apples, and so I spend less time gathering there. I've been avoiding dealing with this up until now by just always using very conservative guesses. But I was going over some of my earlier thoughts about math, and I feel like I can do better than that now. Let's think about a simple example, with 3 trees. Suppose it takes me 16 minutes to pick 6 apples from the first tree, 18 to pick 7 apples from the next, and 20 to pick 8 apples from the last. Overall, it's taking me 54 minutes to pick 21 apples. For now, at least, those final numbers are the only ones I actually care about. It doesn't really matter how long it takes to get the apples from each individual tree, I just need to know how long it takes me to get however many apples. And when I had that thought, it got me thinking all the way back to when I was first coming up with numbers and counting again. Way back then, when I was counting boxes of apples, I had the thought that sometimes I would care about how many apples were in each individual box, and sometimes I wouldn't. When I did, I could talk about having 2 boxes of 3 apples and 1 box of 6 apples, and when I didn't, I could just say I had 12 apples. From the mathematical side of things, these trees of apples might as well be boxes that I'm taking apples out of, with an extra number telling me how much time I spend taking apples out of each box. Since all I care about are the total numbers of apples and minutes in this case, I don't need to care about where exactly the apples and minutes go, which means I should be able to rearrange them however I want. A box of 2 apples, a box of 3 apples, and a box of 4 apples is 9 apples, and so is 3 boxes of 3 apples. The simplest way to think about this would be if there were the same number of apples on each tree, and each tree took the same amount of time to gather from. I can redistribute the apples and the amounts of time, and end up with 3 trees, each of which has 7 apples and takes 18 minutes to pick the apples from. Sure enough, this still gives me a total of 21 apples in 54 minutes. Let's go back to the actual data I gathered the other day, from timing myself picking the apples from each tree. This is a much more complicated set of data, and I don't really want to spend the time shuffling times and apples around to try and even it out. But with division, I should be able to jump straight to the answer anyway. Splitting numbers into equally sized parts is what it's for, after all. I have data on gathering apples from 24 trees, and in total it took me 501 minutes to gather 168 apples. If I divide 168 by 24, I get 7, and if I divide 501 by 24, I get 21. So the results I got are the same as they would be if every tree had 7 apples and took 21 minutes to gather from. I think this is another process that I should have a name for. I'm taking a bunch of numbers and trying to make them all the same as each other. So I'll call it averaging and say that the result I get is an average. The average of 2, 3, and 4 is 3. The average of 16, 18, and 20 is 18. And the average of all these numbers are 7 and 21. This one's different from my other processes in that all of those take two numbers in and give something out, while this one can take any number of numbers in. But division already broke the mold a little for how these things work, so I don't think that's going to be a problem. I'm not going to get too into the weeds on how this should work. I can build this process out of addition and division, which I've already pretty thoroughly explored, so I don't see how it could run into many problems of its own. So now I have this idea of an average tree, which has 7 apples on it and takes 21 minutes to gather all the apples from. This would mean that I can gather an apple every 3 minutes, or 20 apples in an hour. I do need to be a bit careful here, and remember that this average is really just a guess. On a given day, I could always end up accidentally picking apples all from trees that are a bit taller, or a bit farther apart, and get fewer apples. However, I could just as easily happen to pick apples from trees that are all shorter or closer together, and end up gathering even more. On the whole, I think this average should usually be a pretty reasonable guess. But now this has got me thinking. With the data I've gathered, I'm pretty sure I can tell exactly how far off from the average it's possible for me to be. I can look at the trees that it took me the longest time to gather apples from, and consider what would happen if I just gathered from those. Although, actually, it's not quite that simple. Some of these trees took a long time because they were very tall or very far away from other trees, but some just took a long time because they had so many apples on them. And while I spent more time on those trees, I would spend less time on each individual apple. This tree, for example, took me 24 minutes to gather apples from, but I gathered 8 apples from it, so I effectively spent 3 minutes on each apple. This other tree also took me 24 minutes to gather apples from, but it only had 6 apples on it. I effectively spent 4 minutes on each apple here. What I actually want to think about here is, I guess I would say, the rate at which I can gather apples from each tree. This one I can gather apples from at a rate of 1 apple in 3 minutes, and this one at a rate of 1 apple in 4 minutes. But what about this tree here? I gathered 6 apples from this tree, and it took me 20 minutes to do so. I can divide 20 by 6, but I end up with 3 with a remainder of 2. I'm not sure what to do with that. It's not quite 1 apple in 3 minutes, but it's also not quite 1 apple in 4 minutes. It's something in between. On the one hand, I could just stop using minutes here and switch to using seconds, another unit for measuring time, with there being 60 seconds in a minute. If instead I think about 6 apples in 1,200 seconds, I can say that I get an apple in 200 seconds, as opposed to 1 in 180 seconds, or 1 in 240 seconds. But then what about this other tree, where I gathered 7 apples in 20 minutes? I could just keep coming up with new units and pushing this problem down the road, but I think I've hit the point where it's better to rip the band-aid off and start thinking about this problem more carefully. I've been treating a rate as if it has to be the amount of time it takes to get 1 apple, but even in the phrasing of it, I can see that I could just as easily talk about 2 apples in 3 minutes, or 5 apples in 8 minutes, and so on. A rate in this sense is really 2 numbers. one describing an amount of apples, and one describing an amount of time. Sometimes I can divide the amount of time by the amount of apples and get a remainder of 0 to find the exact amount of time it takes to get one apple. But what should I do if I can't? I guess the first thing to do is to establish what exactly I want to use these rates for. I came at this from the idea of trying to figure out the trees that it's slowest for me to gather apples from. So I want to be able to compare rates to other rates. It's easy to do when they're both just amounts of time to gather one apple, but I need to think about how it should work when they aren't. I also want to be able to use them to figure out how many total apples I can gather in a certain amount of time. Again, it's easy if it's just the amount of time to gather one apple, but I want to be able to do it even when it isn't. At the root of it all, what exactly am I doing when I say that if I can gather one apple in 3 minutes, I can gather 10 apples in 30 minutes? Well, the way that I go about finding that is that I divide 30 minutes into 3-minute long chunks, and say that I gather one apple in each chunk. If I gather 2 apples in 3 minutes, well, then I'm just gathering 2 apples in each chunk. I just multiply the previous answer by 2. 3 apples in 3 minutes would give 3 in each chunk, and so on. That's all straightforward, but what if instead I think about 40 minutes? If I gather one apple in 3 minutes, then I divide 40 by 3 and get 13 with a remainder of 1. In each of the 13 3-minute long chunks of the 40 minutes, I can gather one apple, but then I don't have enough time to gather another apple, so I end up with just 13 apples. But what if I gathered 3 apples every 3 minutes? It really feels like if I gather 3 apples in 3 minutes, I should be able to gather 1 apple in 1 minute. But that's not necessarily true, is it? Imagine if I had a really tall tree that took me 10 minutes to climb and had 3 apples at the top all right next to each other. I could spend 10 minutes climbing up the tree, maybe 1 minute picking the apples and 10 climbing back down, and I'd have spent 21 minutes picking 3 apples. But if I'd only spent 14 minutes, I still wouldn't be able to pick 2 apples. I wouldn't have enough time to get all the way to the top of the tree and back down again. So I wouldn't be able to pick any apples. I think it's actually correct to just use the same process and say that in 40 minutes, I would gather 3 apples 13 times, and then not have enough time to gather 3 more apples, ending up with just 39 apples. This makes things a little more complicated. I'd been wanting to say that since an average tree has 7 apples on it and takes 21 minutes to harvest, I could gather 1 apple in 3 minutes, but that's not actually true. There's some minimum amount of time that I have to spend before gathering apples is useful. And when thinking about my average trees, that amount of time is probably 21 minutes. That said, I feel like there has to be more to this. Maybe I'm getting a bit too ambitious for the moment. Maybe there are still some tools I need before I can think about this properly. Or maybe I'm just getting too focused on this one small part of the problem and losing track of the problem as a whole. Whether it's 1 apple in 3 minutes, 7 apples in 21 minutes, or 501 apples in 168 minutes, all of this is just to find an estimate for how quickly I can gather apples. It doesn't need to be perfect, just good enough. Maybe the thing to do for now is to disengage, come at this problem on a new day with a new perspective. I've gotten tied up in thinking about trees and apples. Maybe I need to think about rates in a more abstract way before I can properly make use of them.